Welcome back to Educare Foundation. In this video, we are going to look at how to find the rate of infiltration using the double ring infiltrometer test. So this is an experiment done in hydrology to determine the rate at which water or precipitate infiltrate the soil. And this test was done in the field and this data was taken. Now we are going to find the various parameters that the question is asking us. Once again, welcome back to Educare Foundation. If you haven't subscribed, make sure to subscribe and hit the notification button and make sure to share and like this video. So let's see the question. The table presents observation made during a double ring infiltrometer test at the back of Waska building. So it is a building on the campus of Kwame Nkrumah University of Science and Technology. In a test, a constant water level of 110 millimeters was maintained in the inner ring by adding water as it dropped down to the water levels indicated in the table. Using this information, plot the infiltration rate curve and use it to determine the infiltration rate at the 50th minute. So in my earlier video, you could get it in the description. We explain how this whole test is done, so you would want to check it out for better understanding. But here we are going to look at how to calculate for or solve this question. So first of all, we would continue our table. So what we will do is we need to find the change in water level. Then we'll find the change in time. Then we'll find the filtration at any given point, which is given by change in what? Change in water level divided by our time. Change in water level divided by change in time. So first of all, let's look at the change in water level. Now the water was kept at constant of 110. So minus the water at. So here is going to be dash or zero, and here is going to be 110 minus 95. That's what we are going to find. Uh, so So the filtration rate is given by the change in water level by change in time. Now this is going to give me in millimeters per minute, but these values are very small. So I would want to change it to millimeters per hour so that I'll get huge values so that when I'm plotting my graph, it will be much easier for me. So then I will multiply this expression by 50 minutes because the time is in minutes and multiply by 60 so that I'll get my values in millimeters per hour. You can also maintain yours in millimeters per minute by not multiplying it by 60 and you still get the same value. Just that when we are plotting, you would have some difficulties, right? So let's see. So 15 over 5 times 60, that would be 180. 11 over 5 times 60, that will give us 132. 9 over 5 times 60, that's 108. 15 over 10, sorry, yes, 15 over 10 times 60, that will give us 90. 22 over 20, 22 over 20 times 60, that will give us 66. 14 over 15, that will give us 56. 13 over 15, 13 over 15, that will give us 52. Remember, and the rest continues 48, 42, 42, 43. So with this in place, we will now move on to plotting the graph. Now, we know that we plot filtration on the y-axis, then we plot the time on the x-axis. So let's see. All right, so I brought the data that we had here. So we'll plot our infiltration here. The unit is in millimeters per hour, and we'll plot our time here, which is in minutes. right? Yes. So with that in place, let's see. So let's see how we go about it. So let's say this is one, I'm sorry, one, two, three, four, five, six, seven, 8, 9, 10. That's 10, right? So I can say, let's say 25, 50, 75, 100, 100, 125, 150, 175, 200, and 250. That's my, and here will be zero. That's my time scale. Then on my infiltrometer scale, I'll go 20, 40, 20, 40, will it be 60, 80, 100, 120, 40, 160. Okay, to be possible. So 40, 60, 80, 100, 120, 140, 160, 180, 200. Okay, everything is and we go to 200, right? I just want to adjust the whole thing a little bit so that everything stays inside. So I'm going to use the green marker to do the plotting. So when the time was zero, there was nothing. When the time was five, our iteration was what, 180. So five, this is five. One line is five. So 120. If from year to year is 25, it means that this is 5, 10, 15, 20 to 25. You get it. Right. Then from 10 on the time axis, 10 minutes, then 132. So this is 10 is here, 10 is on the second line, 132 is somewhere here. This is 120, 124, 128, 132. Right, so this 132. Every line is 4. So 132, 136, 140. Right. Then 15, 108. So 15, the third line, yeah, 108. This 100, 104, 108. So it's here. Then 25. So 25 is like 25 against what? 90. So this is 84, 88. If you could see my pen marker, the first line, this is 84, 88 is 92. So 90 will be somewhere here. And so on the 25 line, right? Then we go to 45. So 45 will be closer to the 50. So this is 45, right? And 45 goes with 66. So this is 60, this is 64, this is 68. So 66 will be somewhere here. This is 45. So it's going to be again. Then 60 itself goes with 56. So this is 55, 60. It goes with what? 56. So I'll say 40 is here, right? 56. So 1 to 60. So it's here. It's 56. And 75 goes with 52. So 75, 40, 44, 44, 48, 52 is here. The 90 is 90, 95, 100. So 90 goes with 48, 90. This is with 40, 44, 48. Then what? 110. So 105, 110 is here. Goes with what? 42. So this is 40, 44. So 42 is going to be in between somewhere here. Oh, what is this? Then 130, 130, this 130, also 42, then 150, 250. Then we plot the graph. I'm using a black line, so I just join. Oh, sorry. I'm using my full answer. Make sure it passes through the point. It's not passing through. Forgive me. So there it is. Then you just extend this line backwards somewhere here. So let's see what the question asks us to find. The question states that plot the infiltration curve and use it to determine the infiltration rate at the 50th minute. So we have to look for the 50th minute. Trace it. This is the 50th minute. Let me change the color. So this is the 50th minute. Trace it to touch the curve and trace it back. That is what. So the answer is 60 millimeters per m. That's the infiltration rate. Thank you very much. And check out the explanation video on this in the link below or what is showing at the top. See you in the next video. Bye.